Hi, I'm Bob Vavra, Senior Content Director for Machine Design, and welcome to another Machine Design Quick Chat. Today, we're going to be talking about new technologies for a traditional plant component. DIN rail terminal blocks are used throughout multiple industries, integrating components within an individual machine to integrate multiple machines into a complete factory system. Now, both electrical and electronic devices are easily integrated using multi-use terminal blocks for a wide variety of industries, including aerospace, medical, oil and gas, automotive, semiconductor, packaging, transportation, power industry, and there are more applications coming even from that. So we're going to talk about DIN rail terminal blocks today with Markus Kraess, the product manager for Altech. Markus, welcome to the chat, and we've got a lot of things to cover this morning. But let's start with some of the basics. What are the features that you need to consider when you're selecting a DIN rail terminal block?
Yeah, good morning, Bob. Thanks for having me. Good question to start. So I think first of all, users, they're looking for a terminal block. They're easy to install. It has to be low in maintenance. It needs to be highly efficient in the required environmental conditions, and also it needs to be compact in its design, as it's possibly that's an application where you need to connect many wires in a very high density of panel space. Some other users, speed of installation could be important. So, and at the end, each application there has different needs. So the customer, they need to or might have to prioritize one feature over the other, because, for example, an easy to install terminal block, might not be the most efficient, or the most compact one, could not be the quickest to install. So. Besides these general features, a user, they also need to look at basic electrical, mechanical specifications or environmental requirements and conditions. Questions here to answer would be, for example, what's the size of my wire? What maximum current voltage is needed? Do I need any specific material and certifications due to certain environmental conditions, or is it in any special hazardous location? Very important, how do I lay out my electrical circuits? Is there, for example, a special terminal block needed, which needs a fuse, for example, or needs to be disconnected? Some designs, they require different colors, to differentiate between different circuits. So I need to make sure these colors are available for this block type. And also, it's not only the block. So each block has different accessories available. So do I have, for example, the right partition plate? Do I have a jumper system that fits my application? Do I have marking options? And all these criteria the user has to go through when they select their terminal blocks, because at the end every application has different needs, and they need to make their decision what to use.
So you talked a little bit about push-in DIN rail technology. Let's talk about that for a second and talk about how push-in DIN rail terminal blocks actually operate.
Okay, so screw terminals, they're mainly used in the distribution of electricity in homes, warehouses, plants, factories, and inside all types of panels and junction boxes. So they're around for a long time, and that's really also the connection technology, which is most dependent on human interaction. Since I do have a screw that needs to be tightened, and that has different torque values, so that really depends on the human to tighten the screw. And when there's usually human involved, there's also room for more failure. So how do screw terminals operate? They operate simply by I do insert a wire into a clamping system, which is mostly an elevator type of clamp. I tighten down the screw, yeah, to a specific torque value using any type of screwdriver. And yeah, but nowadays, yeah, screw terminal blocks, they do incorporate some kind of locking features. And because usually, yeah, screws can loosen up over time, yeah, due to shock and vibration. So some of these locking features, they guarantee then a safe connection and also prevent the screw from yeah, loosening or opening up. Mostly screw terminals, they're used then when there's need for large wire sizes and especially for high current applications. Clamps are usually made of a steel material. Yeah, and then there's a more specific or special type of screw terminal where we use, for example, a ring lock or a stud to connect the wires to a terminal block, or that's how they're terminated. Nowadays, there's many users. They're also familiar with like spring or cage clamp terminal blocks. Here, the human involvement factor is a little less than on the screw. I still need a tool, so which can be any standard screwdriver. That is still needed because I need to open a preloaded spring. But the difference to the screw terminal, so we don't need any, don't need to tighten any screw. So there's no torque necessary to make a safe connection. And as I mentioned before, the less human interaction I have, the more safe and fail-proof usually my system is, and that connection then is guaranteed by that preloaded spring. So how do I operate a spring or cage terminal? Yeah, so I do insert a screwdriver into a slot on the clamp that opens up the preloaded spring. Yeah, once my wire is inserted into the open terminal, we remove the tool, and then the spring force, it presses against the conductor against the current bar, and this is how I have a safe and secure connection then in less time than I would have on a screw terminal. And because of this, because of the resistance to vibration and shock, because the screw is less prone to open up, those terminal blocks, they're usually designed in and used mainly in elevator cabinets, in railroad car applications and other machines and vehicles. Clamps, they're usually made of a stainless steel material to really guarantee that strong connection. Yeah, and now as innovation and design possibilities move forward in DIN rail technology, so there's advancement in materials and design options. We have a push-in terminal block now, and they are more and more become available to engineers and installers. And here the biggest difference is, so I hardly have any human interaction. We don't require a tool to make a safe connection. And it also has a stainless steel built in to guarantee that safe connection. And they really work well for most automation and robotic wiring situations.
Yeah, you talked a little bit about some of the benefits from a non-human interaction standpoint. Talk about a little bit about how they operate, first of all, and then we'll talk about some of the customer benefits.
As mentioned before, so both screw and the standard spring clamp terminal blocks, they have more or less a bigger a human factor built in for wiring. Since I do need to tighten a screw, or we need to open a preloaded spring. Now with the push-in wiring here, it really allows the user to simply push in a solid or a stranded wire with ferrules into the terminal block itself, and this gives me then a really quick and reliable connection. Yeah, and just that push-in aspect alone, that at the end also saves me a lot of time in my installation, and later, yeah, I have much less maintenance than I would have on a screw terminal block, for example, which might need to be retightened over time. Mm-hmm. Yeah. Besides the quick installation time, there's other benefits as well to a customer. So I have to say though that most users, they would probably answer that question of the benefits, that the key benefits is that toolless connection, and this would be resulting in much less wiring time, and therefore also installation time that I have at the end. I can give you some numbers, yeah, to compare the different connection technologies. Yeah, when I compare, for example, a regular screw clamp terminal, just by using an automated screwdriver compared to manual hand screwdriver, that already would save me 20% wiring time. Now, when I use a regular spring terminal to install my wires, here we talk about a 50% time savings on installations. But when we get into push-in terminals or push-in terminal wiring now, here wiring time is really cut down by almost 75% over a regular screw terminal. So that's really significant. And when we have very large panels with a lot of wires, so users can they streamline their installation process, for interconnecting all their wires, and we can also connect different types of devices like sensors, I/O, and DCS systems, and that's usually in large process and automation control applications. Now, besides the wiring time, there's also when I push in the wire, there's a certain insertion force into the terminal. Some might think this is actually quite high, but users can benefit from a very minimal insertion time here. And that makes it also very easy to connect very small wires to connect in a push-in terminal block. Another benefit of the push-in terminal blocks is, for example, the pull-out force of the wire. So once it's connected, it's very hard to pull out the wire, and here we really see big differences between a push-in terminal block where the pull-out force is much larger than on regular screw or spring terminal blocks, and that makes them really reliable, and low maintenance later, and also very suitable for long life applications. Also, these large pull-out forces, I talked about this a little bit before. So users don't have to worry at all about any shock or vibrations that the applications might be exposed to in the future. Another furthermore a benefit is it's the high density wiring that comes not so much from the connection itself, how I connect a wire into a terminal. So it's really the unique design of these terminal blocks, and that allows them to be designed very thin compared to screw terminal blocks. So here a push-in design actually allows a size reduction of about 30% of a terminal block size compared to a screw technology. And there's, for example, 3.5 millimeter wide terminal blocks in the push-in terminal blocks, and you can still connect a 14 gauge wire into that terminal, whereas screw terminal blocks usually just go down to 5 millimeters wide, and that difference can be significant when we have a large amount of connections in an electrical panel. And of course, push-in terminal blocks, there's other advantages as well. Advantages they have with any screw terminal block. So they come with all the accessories available, different jumper options, different marking options from different angles, and most of other accessories and colors are available with the push-in terminal blocks as well.
What are some of the block types available with push-in technology?
Push-in terminal blocks, they're in general pretty much available in the same types as all other connection technology, like the screw and the spring or cage clamp. There's regular feed-through terminal blocks. Different types of like double and triple level terminal blocks. All these usually come in all different versions with grounding options. There's various fuse terminals available also, mainly for different fuse sizes, fuse types. These fuse terminal blocks, they also come in multi-level, multi-configuration options where we have additional feed-through terminals and grounding options. Or instead of the fuse terminal, we can have disconnect terminals as well. Now, what's unique to the push-in terminal blocks? So since we talked about density wiring before, which is one of the most benefits of the push-in terminal blocks. So there's for example a marshalling block, and that has 32 connections in a very compact space. And also there's 3.5 millimeter wide sensor and actuator terminal blocks, which really prove to be useful when we have high density multi-sensor applications with a lot of wires that need to be connected. And those two, those would be really the ones, which would be unique compared to screw technology within the push-in terminal blocks.
Okay. We've covered a lot of ground here on DIN rail terminal blocks, and particularly on push-in DIN rail terminal blocks today. And I want to thank Markus Kraess, the product manager for Altech, for joining us today at this Machine Design Quick Chat. Everybody have a great rest of your day.
Thank you.